Okay, guys, we meet again in these sessions. We are talking the third process in the methodology A for analyze phase. It's obviously in analyze phase is we are going to analyze all the data that we collect before in the measure phase, and then we try to identify the root cause. So we are able to give the solution based on the root cause identifications. Most of the final projects for undergraduate level is trying to give problem solving for organizations or industry or company. So this might be primary process for us to use all of our knowledge and ability to find what data we are going to collect and what methods that we are going to use for analysis and identify the root cause. And then finally, we can give problem solving for the company based on the analysis upon the data that we already collect. So in this analysis phase, we are trying to identify the source of the variance. Let's see what is the relations between X and Y. So in previous materials or previous video, it's talking about that when we have a process and then we give the product to the customer, and then let's say our product is bag, yeah, the spoon bomb bag, and then we try to identify the customer requirement and translate the customer requirement into what we call as CTQ. So CTQ here we call it as Y. Yeah, so if we still can remember what several example of CTQ for the bag production is like jahitannya yang rapi, kuat, tas yang bersih, kemudian dan penempatan tali yang tepat. That's all we call as the Y, the customer CTQ. And then we are try to trace back to the production process, trying to trace to the production process, and then we find out that shoeing process was one of the critical process. And then we trace back again to the parameter that might influence to the process, and then we call it as X, the parameter. So in this analysis is said that this is to search to the filter X here that might drive the Y. Yeah. So various statistic and quality methods that you can use in this phase are 5 Whys, and then the diagram Ishikawa, cause effect diagram. Everybody mostly familiar with these tools, and this is new one. Value mode and effect analysis Pareto chart is also we discussing. We use it in many projects and many assignments. Hypothesis testing and ANOVA, we learned many of tools in statistic industry, regression and DOA. So we are trying to refresh and discuss these tools. So if you see this example, yeah, for the problems why customer wait too long on the phone at the end of the month, the problems. Usually if we use the Ishikawa, we are trying to identify the root cause from many cautions from the methods. Is there problems of the a problem on the procedure of customer complaint, and then we look at the operator. Do the operators have no capable in handling the customer complaint, and see the machine the problem on the phone, and then the internet connections, and so on. If you use the diagram Ishikawa, we are trying to identify the root cause from 4M1E, man, methods, material, scene, and then environment. But if we use 5 whys, we are innocently asking whys for 5 times. Hopefully, we can find the root cause. So we can see here, why customer wait too long at the end of the month when they make a phone call? Because at the end of the month is the busiest time. Why the busiest time? Because the company offer more incentive to the customer late in the month. Why? Because sales always didn't reach the target at the end of the month. Why? Oh, because the customer have learned that if they wait for the end of the month to put order in the company, they will get incentive. Why? Because they can identify that sales targets are done on monthly basis. So after we asking why for several times and then we get the cost, then we can make the action plan. The action here is rather than monthly basis, we better make weekly sales goals to prevent the customer waiting too long on phone at the end of the month. So in order to use 5 whys as an effective RCA, root cause analysis tools, you need to train yourself to ask right questions. Yeah. Here are some tips that you can train yourself to ask right questions first. Is there any data or proof or facts that can support your questions? This tips is usually used by the reporter when they are asking interview with someone. Yeah, they collecting the data first. Other tips is there any historical data or experience before, previous experience? And this is why when we want to ask root cause, we usually came to the experienced staffs or workers or even senior management. And we think that they might have a lot of experience that can give us insight. And others is we try to identify other root cause. Yeah. Usually if we want to help the company solve the problems or maybe our friends out of their problems, I usually practice it when my children have problems. I innocently asking 5 why several times. Yeah. When we want to see the problems, we have to put the problems out of ourselves so we can see it clearly. Like you fly out of the earth and you are an astronaut, and when you are out of the earth and you can see easily, obviously, what earth is. So similarity with that, so we can, if we can put out the problems out of ourselves, we can easily see the problems, and then we can easily identify any root cause. Yeah. So when someone told me that it's hard to ask 5 whys, maybe when they are asking 5 whys, they are standing in the same point of view with the workers. Yeah, because workers is already a long time with their problems, with their system, and then they are accustomed to their system. And then if we are stand in the same point of view with them, we are hard to find the root cause. So if you are able to ask right questions, you try to step up. step out from that point of view and try to see the problem out of yourself, and hopefully you can help the company identify the root cause. Okay, so 5 whys not always become effective tools for you to identify the root cause. It can be failed too. If you don't ask right questions, you won't get the right answers. So you see that one of the reasons why 5 whys fail is blaming. Yeah, when we didn't ask the right questions, people feel they are blamed. And when they are blamed, they are start to resistance. Because blaming may be an effective root cause analysis, but if you can develop tools that can reduce or eliminate blames, hopefully you can help the investigator find more root cause and develop more corrective actions. The next video I will show you how 5 whys can be failed to identify. You might get the answer, but the answer means nothing. And then let's try to see a project example here. We can see that one of the critical to quality is payment received on time. It measures from the date of invoice issued to the date of payment. Yeah, it's also one of the financial ratio when you learn in analysis biaya or when you do at KP1. Yeah, one of the ratio called as ACP, average collection period. If you have ACP 1 day, it means that your business is very good. You serve for today and then you get the money tomorrow, 1 day. Yeah. Or even 0 day or 100% down payment. You have to pay first. Customer have to pay first before they receive the product. And also you heard the terms of COD, cash on delivery. Yeah, you send for today and then they receive the next 7 days and then you will take your money when they receive your product. So this is 60 days, the specifications. So people usually say net 14, it means 14 days, net 30, it means 1 month, net 6 and net 60 is 2 months. Yeah, some government projects have a very long payment period. Yeah, took about 2 to 3 months. Next, net 90 or net 3 months. So we look at an invoice as the unit of the collection data, and then we get the invoice from the account department. We use the data collection method, pre-existing data, 3 months from January to March using random sampling, and then we get 43 data. So there are many tools that we can use. One of them is cause effect diagram. Cause effect diagram is try to understand what parameter or what kind of the problems that might cause customer pay late to us. Yeah, invoicing methods or customer related problems, invoice related or others problems. And then using this diagram Ishikawa help us to, when we collect the data, yeah, we see 43 data here. Yeah, beside the data that we collect as days, yeah, days. This is the data actually we want to collect for the first customer pay for 53 days, and then the second customer pay for 63 days. Yeah, we see these variations in payment day. Yeah, but using the diagram Ishikawa can help us to identify maybe there are many factors that influence customer to pay. Yeah, maybe the number of the amount. Yeah, maybe our hypothesis is the amount of the dollars is higher, then the longer they will pay. Or maybe the kind of the methods. Yeah, usually using transfer is faster maybe than the check or electronic data interchange. Or maybe because the locations is inside the town with the same town with the same locations with the company, or in the locations outside of the company. Or maybe the invoice problems, there is no error or there's some error in the invoice. The information in the invoice has some mistake. So don't forget that the data here, the dollar is in thousands. So there is another tools that we can use is hypothesis testing and ANOVA. Yeah. In our hypothesis that locations might influence the payment date. So we're testing it, and then we get the pay value. Everybody know that pay value is less than, if the pay value is less than 5%, we reject the ANO. Yeah. So this is more than 5%. It means that the location is not significant. It's support by the confidence interval that there's have intersections among the locations. It means that there's no difference payment day that caused by the different locations. So let's continue for the next analysis. Yeah, we see here the payment method. We see the payment method influence the payment date. Yeah, if they're using the ADE, it's faster. If they're using the checks, it's longer. Yeah, so if you have the information here, you can encourage the customer using the EDI or the transfer pay method. And then also you can use the regressions, yeah, the regression analysis that we saw here. The regressions, it's look like there's no trend like this, yeah, it's look randomly here. So we can say that the amount of the invoice didn't influence the day, yeah. So we can also check more details using subgroup, and then also there's no impact, and more specifically the regression analysis here, yeah. We can see the regression analysis. We can see which factor that impact the regressions. Yeah. The payment methods, three of the payments method, and then error in the invoice also influence the payment date. Yeah, and the important is from the regressions is we get these regression equations. We can predict someone with a certain characteristic that they pay using the transfer, or there is an error or not in the invoice, and where is the location, we can estimate the payment date. Yeah, so this is the one of the significant impact using the powerful regression analysis. And the next tools is the process capability. Everybody familiar with this output, the mini-type output, and we can see that the process is controlled by one site specifications is the USL, yeah, maximum 60, yeah, maximum 60, yeah, lower than 60 days. This is the spec, and then we can see here the process is not very good. Yeah, the CPU is less than 1. Yeah, it's very poor. And then we also can see the information here. Yeah, can see the information here. We use the within the information. We don't explain it here. You already get it in your PKS subjects. Yeah, why we use the within, not rather than instead of overall standard deviations. And then this is the USL, and then this is the means from the data from the 43 data. We get the average collection period is 56 days, and then this is standard deviation. We can put the formula here. Yeah, we use it here. If you don't remember the formula, open back again your book, your PKS book, and figure out the formula to help you to calculate the CP, CPK, CPU, CPL. Yeah, then we can tell that this is not a good process. Bad, less than bad process. Yeah, bad performance. Yeah, and also we can see here. Yeah, we use the within the and then the Minitab already help us to calculate the DPMO. Yeah, so guys, this is the DPMO. Yeah, so this is the DPMO. So from here we can see that the DPMO is 327,591. And then you can put this DPMO into the sigma calculator in order to know what sigma index that this process had. So we can call it as our baseline. Yeah, baseline. Actually, process capability is one of the measure activity. Yeah, some of them put in the measure phase, some other put it at the analysis phase. Yeah. So since ISO 9001, the newest versions, is talking about the risk management. This tool suddenly become famous because it's used along as the risk management. Yeah, it's like the coronavirus, suddenly famous. Yeah, it's called FMEA, Failure Mode Effect Analysis. From failure mode effect analysis, we will understand what we call as the risk priority numbers. Yeah. So we try to identify any risk, any failure that might be happen, and then we try to calculate the RPM. So the failure which has high RPM will become the focus of the action plan, the improvement plan. So the general template is like this. Yeah, yeah, you can search any template here. You can search any template. Yeah, the product, the process name, who is the PIC, and then who prepare it. Usually it's the offline people is trying to identify any failure before the process running. Then who make it, what date, what is the revisions, yeah, what is the revision edition. Yeah, so we can see here what is called as RPM, risk priority number. Risk priority number is the multiplications of the severity as this one, and then with occurrence, this one, and also with the detections. Yeah. So some people using the severity, the occurrence, and the detections from number 1 to 10. 1 is good conditions, 10 is bad conditions, and then some of them use 1 to 5. Yeah, it depends on the reference that you use, but we are going to use 1 to 5. Sorry, 1 to 10. Yeah. So we try to identify the process. Yeah, what kind of the process? Yeah, as uh, the bag manufacturer, we have 4 process, from persiapan material to the penjahitan, and then penambahan accessories, and then packaging. Yeah, that we call as process. Then we identify the sub processes and any failure that happened in the process and the effect, and then we try to measure the effect. Yeah, so severity is the impact of the effect, the impact. And then what is the cause, the root cause, how often it happened, we call it as occurrence. And then if the failure happened, and then is there any detection mechanism that we have? If we have, and then how easy the mechanism detect the failure. Yeah, so people usually calculate the initial LPM and then try to solve the problems, and then recalculate the LPM if the action is done. So there is many reference define the scale from 1 to 10. Yeah, but although there are many references talking about it, some company try to adjust again in their conditions. Yeah, so severity 10. Yeah, 10 means that it's very severe, parah. Yeah, 1 is yeah, people maybe didn't notice it. It's like uh, the point of view of employee. Yeah, we're talking about the safety problems. Yeah, if the failure is related to the exploded machine or fire in the building, we can call it the severity 10. Yeah, the severity 10, although it's seldom to happen. The detection, the occurrence might low for the explosions, but the severity, if it's exploded, employee might be hurt and bring to the hospital. So it's called severe impact. But if one is like the uh, smelling is not good, yeah, caused by the waste of the company, yeah, it might not influence to health, maybe, yeah, we can call it severity close to lower number. So there is other definitions about severity, other description about the severity, yeah. So it's dangerously high, it's not. Just now we talk about the perspective of the employee. If we talk about the perspective of the customer, the severity can be referred like we have bags, yeah, we spoon bone bag, yeah. So level 1 severity mean that there is just a black note, the dirty, a little bit dirty dot in the bag, so it's might cost nothing to the customer. But if the pegangan tasnya kurang satu, or the bag tasnya jahitannya kurang bagus sampai terbuka-buka, ya, apa namanya, talinya, benangnya, ya, it can cause danger high that people cannot use it, customer cannot use it, ya, it's might categorize at 8, maybe kegagalan membuat produk tidak bisa digunakan dan tidak layak digunakan. Yeah, 9 or 10, usually maybe they use for the food product, they use the bahan pengawet yang melebihi membatas, atau penggunaan formalin yang berlebihan untuk tahu, misalkan seperti itu. Severity, and then it's the description of the detections, yeah. If our mechanism, our design control is not able to detect the failure, we call it as level 10. Our detection mechanism is absolutely uncertainty to detect the failure. But if we have a very good detection, yeah, detection like the smoke detection, if the fire happen, yeah, the design control hampir mampu mendeteksi, we can categorize it at level 1. It means that our detection mechanism is very good. Yeah. Next, occurrence of occurring usually in number 50% happen, we categorize it as ranking 10, and then seldom happen, it might be 1%, lower than 1%, we can categorize it at level 5, higher than 1%, we can categorize it level 6, and so on. Yeah, so that's it. So this is the example of the FMEA in the ATM. Yeah, we are trying to see which RPM is the higher. We can see here. Yeah, when we go to the ATM, and then this is the problems that company try to identify, and then this is the failure that is categorized at the high risk priority number. Yeah, this is talking about the ATM has not dispersed. Yeah, there's when we go to the ATM and then we don't get the money that we want, that caused the dissatisfied company. So people put it severity level 7. And then what problem? Yeah, there's no money in the ATM. How come the money came out if there's no money inside the ATM? So occurrence, it's often happen. Yeah. Why? Because the company didn't have the alert system to let them know that the ATM have already low cash. So the detection is poor. Oh, I mean that Oh, they have the internal alert of low case. Yeah, so the detection is good. Yeah. So since this become the high prior risk priority number, so action needed. Yeah, increase minimum cost threshold. Yeah, they need to do any actions. Yeah, so when we put the action here, yeah, some people using the Pareto, they are ranking the risk priority number from the highest to the lowest, and then they take the 80% of the highest become the focus of the action plan. Yeah, it can be, or some set the number. We are going to do the action if the RPM is higher than 100. The company set the baseline like that. Yeah, so there is several various methods that you can use to help you to analyze the problems. Okay, the this one's of 5 lines, and then diagram Ishikawa, FMEA, Pareto chart, hypothesis testing, ANOVA, regression analysis, and the design of experiment. Design of experiment is more advanced. Yeah, I have a student that ever do the Lean Sigma, and then when come to the solutions, we are trying to do the design of experiment, and that the final project become a very good one. Yeah. Okay, that's all for today. Then see you at the next meeting. Bye bye.